for all the null sessions that I've done, I barely use the mic. Right?
Yes.
I'm usually known as a very loud person. It's a compliment. Right? It's not like people are calling me obnoxious. My name is Riaz. I'm going to be talking about over the last course of the decade and a half doing pen testing across different systems, across different cloud providers and stuff. There have been certain experiences that I have seen and carried forward in terms of this bug led to another, and then there was a bunch of multiple vulnerabilities that were chained to eventually get shell access to a system or access to data that the customer didn't want us. I'm co-founder of Cloud, and I'm the chief hacker there, right? So essentially, I lead the R&D team, and we pinpoint misconfigurations in different types of cloud providers, set up services which I hack them and then report them back to the providers and add those misconfigurations back in our tool, right? The case studies, for the lack of a better word, as I call them, these are across different types of services, but all of them focus on AWS. And we've seen them happen through web applications, through network endpoints, right? And I've kind of woven them into 3 different case studies and the stories, right? All of the stuff that you would see on the slides has been recreated as part of the presentation, okay? So obviously, I haven't hidden any IP addresses or domain names and stuff. They don't no longer exist, but because simply they're recreations of what happened, right? We're going to see common security misconfigurations that lead to access to systems and data beyond the plane of attack. And if you folks, I see some of you, bug bounty hunters and stuff here, the kind of impact that you would present, right? And Shubh's kind of mentioned it, that the payout is higher, definitely, if the impact is shown to be higher, right? In all of these cases, and none of these are from bug bounty reports and things, these are valid assessments that we've run in the past. And we've had to show proof of concept of compromise, of the impact that something would lead to. And the initial foothold has been unrelated cloud vulnerability, but because of misconfigurations in the cloud provider itself, the impact was high. Right? So we're going to look at those. A common theme you'll notice across all 3 scenarios, all of them are AWS service level misconfigurations. I'm not allowed to talk about the other 2. Right, being in the premises that we are, but all of these misconfigurations amplify the attack, right? You will see a common pattern where dev folks tend to do non-devy insecure things, right? We're going to see some examples of those, and I'll leave it open for you folks. I'll ask you a question. What do you think happens next, right? So let's see what happens then. A lot of overly permissive policies, and if you work with a cloud provider in your organizations, you know, right, that there are cases where you've given overtly privileged permissions, roles assigned to services, just because you had to get the work done, right? You had to have the service execute, you had to see the output. So you assigned admin privileges, those asterisks that you keep adding to your permissions and roles. The absence of logging or poor monitoring when logging was present, right? That's another thing that leads to, that's another theme, underlying theme that you'll notice. And potentially sensitive data that's not encrypted at rest, right? You may have a compliance checks that tell you that, if data is stored in an S3 bucket, now S3, you no longer have to enable encryption. SSE is enabled on AWS, as we said about a month and a half ago. But if the attacker has valid credentials to your S3 bucket, right, the encryption of the data at the data center is irrelevant. You have permissions, you're accessing the data as a valid user, right? So cases of those as well we'll see. The first one, and all of them are my favorites across the different assessments we've done. None of them stand out as such, but you will be able to relate with some of them, right? Definitely. I call this misconfigured bucket to system shells, and why? Obviously, you should never leave your buckets open to the world. At the very beginning, there was a domain called Galaxy Butter, right? This company, successful company that supplies dairy to other planets and stuff, right? The idea behind this, like if you're going to be an attacker and if you're going to start a reconnaissance, right? One of the first things that you would do is, which is what we did, right? And there are multiple attack paths, by the way. When you look at a particular application vulnerability or anything that I'm talking about, there is going to be different attack paths that you will take based on how much information you have, based on how much time you have, right? So I'm talking only about the attack paths that we took that led to successful execution and chaining of vulnerabilities. we fetched the DNS records for galaxybutter.co. We identified NS, CNAME, SOANT, TXT records. And this is required because it kind of tells you a lot about the underlying infra. As soon as we did an NS, we noticed the name server was a DNS provider. Was an AWS provider. And we then also did a TXT record lookup for the galaxybutter.co domain, right? These are results from the NS record lookup, because the most complete information is going to be of a particular domain is going to be on the name server provider of that domain, right? So in this case, AWS DNS hyphen any of these would have worked. The CNAME record for GalaxyButter pointed us to an S3 bucket, right? So galaxybutter.co was simply pointing to an S3 bucket in US East 1 region. That's good to know, because we know the infra is now should definitely AWS. We looked at the TXT record and we found an IP address, right, in the SPF record. What do you do when you find an IP address? NMAP. Excellent answer. So the port scan results for the common 1000 ports led to the discovery of SSH. Right? That was the only port that was visible. And if you notice, this is the nmap command that I use if I'm going to be running an assessment. And notice the usage of -G80. Right? Very rarely, I still do find use cases where setting the source port of your traffic leads to some some loosely configured firewalls.
But why do you use top ports 1000 by default?
Yeah, I mean, I wanted to show that we ran a longer scan. I ran for the entire 166.5.35 set, but I wanted to show the command here, right? In any case, like most of us who run nmap, we don't run it once, we run it multiple times. So we have SSH that was open. And what do you need to SSH?
Keys. Password. Depends.
It depends, right? So you need either a password, username password combination, or you need a private key. We don't have a private key, right? So we went back. We had the name of the domain, galaxybutter.co, and we had the name of a bucket as well. So we ran enumeration using one of the oldest tools ever written for bucket discovery, DG Ninja's bucket finder. And we noticed, essentially for open buckets, if you're trying to discover them, a 404 means no bucket, right? The bucket doesn't exist as long as the region is right. And a 200 OK would mean that the bucket has content that is being displayed. I don't know if it's visible, but we did find dev.galaxybutter.co, and there was a zip file present in that bucket. What do you think was in the zip file?
No.
Private key.
Absolutely. There was an SSH key present within the zip file, along with bunch of other files and source code information.
RC.
Once you have the private key, you could also obviously go back and take a look at the source code that you've just discovered. See if you can do source code review and discover more bugs. But we didn't care. We had a PEM file, and now we need to find the machine on which the PEM file would be valid. Right? We had an IP address, but obviously it didn't work there. And because we had a larger scope when we were running the assessment, although the IP address that we discovered, we didn't find it there. But eventually, we did discover a machine on which the PEM file worked. And we SSH'd into the machine. And from there, we did additional discovery. Right? And using the external IP address of the other machine, we were able to identify more keys.
That was not AWS, right?
This is still AWS. All of this is still on AWS.
IP.
Yeah, right. Once we've done this, we looked at, and this is common Linux post exploitation stuff. You go look at different files and folders, and we were able to discover a directory which contained a file that had DB credentials, right? Using these DB credentials, again, from the name itself, you know that this is set up. We were able to connect to the database and dump accounts and product information.
Your favorite area.
Yeah. And so I didn't have to do SQL injection, right? I had access to the database credentials from SSHs. Okay, so that was one. You see the progression of the attack, right? So we went from doing DNS enumeration to discovering IP addresses, then doing bucket enumeration. You're at a different plane right now, right? You're no longer at the web application level or the domain. You've now started attacking the cloud infrastructure. The second one, SSRF2 shell by IAM policies. I'm horrible at naming stuff, so let's call this case 2. This is very similar to the Capital One breach. A lot of you folks are young, but about 4 years ago, Capital One had a massive breach where a ton of data was leaked from one of the public buckets. Right? I call it public because the key was available. At the beginning again, let's start from here. We had access to a page which had login information. There was a login page and there was a user registration page. So a web app with a login page was discovered, and the application had the ability to register new users, right? As goes with any web application security vulnerability discovery, you register with a new user and try and figure out if the application looks different or has different vulnerabilities available to a registered user, right? And in almost all cases, the amount of access a registered user has is definitely far more than what a limited user has with no access. The applications, one of the functionalities allowed us to provide a URL and make a web request on the behalf of the server, essentially trusting user input with URLs that would be used to make a request from the server. You've heard of this before. What vulnerability is this? SSR. Because Spider-Man trusted. Okay, never mind. So, the combination of SSRF and cloud applications on virtual machines that are running on the cloud, I call it bad because there's far more information that you would be able to obtain if a machine is on a cloud provider than if it was running on a machine. Right? VMs across different cloud providers, AWS, GCP, DigitalOcean, and others have a service accessible only from the machine itself. I can see only 3 cloud providers there, so yeah. On EC2 type machines that are hosted on the cloud, this service endpoint, the instance metadata service endpoint, is accessible at this static IP address. And this is a non-routable IP address. So you have to be on the machine to be able to access this IP. Right? And for EC2 type machines, and I'm specifically calling them out as EC2 type machines, as in virtual machines, the endpoint is also available on other compute resources, like you have Lambda, right? Or ECS. The IP address differs for them, but they are available on all types of compute resources. This particular IP address is for virtual machines. The endpoint, if some of you nodded in information that you've seen this before, the endpoint contains information about the system, right, pertaining to the cloud infrastructure. And so instance ID or the unique token, the unique identifier for the machine on the cloud provider. And different cloud providers have different kinds of information. AWS is interesting because in AWS, when you attach a role to a machine via an instance profile, temporary credentials for that particular role that has been attached to the machine are available through this endpoint, right? And this is done because if you have a service or if you have a program or an app running on the virtual machine, and if you want it to do cloud stuff, it is a horrible idea to store access keys belonging to an IAM user. And you have to work with the role. It's considered to be the more secure way of doing stuff. Right? You add the role, give permissions, not stars and stuff that people usually give, but give it specific permissions that you want for it to act on a particular service. Attach that role to an EC2 instance, and that role then becomes accessible through the machine itself. Which is what we did. Use the SSRF to query the IAM security credentials endpoint within the machine, and the role was called EC2 server health role. We were able to use this to generate temporary credentials. Okay. Now, when you have temporary credentials for AWS, when you have an IAM user, there's only 2 pieces of information, right? The access key and the secret key. When you generate temporary credentials using STS or assume role or using instance profiles, you have 3 pieces of information, right? You have the access key, secret key, and there's a token. Okay. So when you configure this on the command line, you can do an AWS configure profile, whatever profile. You have to also go then and edit the credentials file to add the access token. Or you can use an environment variable to export the token on the command line. Once we had the credentials configured. We enumerated who we were, right? As a pen tester, it's very important if you've obtained credentials or if you've obtained some sort of access, you need to ask yourself 3 questions, right? Who are you, where you are, and what is visible from where you are. Right? So these essential 3 questions is what I always ask whenever I have gained access. So that's what I did. Figured out who I was, and now I needed to know what permissions I had. I'm skipping the bit where we did the enumeration, like a bunch of tools available, but essentially the attached IAM role had permissions that gave the creds the ability to perform actions beyond the EC2 instance. And that's what the role permissions are designed for. You would require them to say, for example, if you had an application that would upload resumes to a website, right? And the website is actually taking the resumes and transferring them to an S3 bucket. How would the VM, the EC2 instance, write to the S3 bucket? Not using IAM hardcoded roles or credentials, but using an IAM role that has write permissions to an S3 bucket, to a specific S3 bucket. Right? That's even more hardening it, locking it down. But we were able to use the credentials to list all the buckets within the account, and we looked at a bucket called data.serverhealth-corporation, and we were able to sync that data locally. Okay, there was a CSV file called data001 which contained credit card information. Again,
Violation. PCI DSS violation.
Yes, in plain text. Why? Because you pass the compliance check that the bucket is encrypted at the server side. So AWS folks can't see your data, but anybody else who has access to your keys, where in SSRF, doesn't matter, they can see your data, obviously. Right, so I haven't obfuscated again. What do you do next? Because I still wanted a shell, right? Shell hungry usually. Using the credentials that I had now, the IAM role temporary credentials that I generated, I then looked at the AWS SSM. Right? The EC2 Systems Manager is a service within AWS that allows you to execute commands on an EC2 machine without having SSH access. Right? Because most machines that were created after, I think, November 2016 have a binary running within those machines that talk to the AWS APIs, right? And you can communicate to the machine via the APIs. Right? So obviously, there's authentication required. Basically, use the CLI to send a command to an AWS service. An agent running on the instance is contacted, and the command is run as root. Okay? If it's a Windows machine, it's run as administrator, but on Linux, it's run as root. Using that, we were able to execute a command on first you have to enumerate the machines on which the EC2 instance, you have to enumerate the EC2 instances on which the SSM agent is running. Once you've enumerated that, we had one machine as an example here. We were able to send a command. What's the command I sent here? Yep, ipconfig, right? So if config in terms of Linux. So if you notice the command is equal to if config parameter, that's a command. You send the command, you get a command execution ID, then you query the command execution ID to see the content of what the execution was. And in this case, we were able to execute if config on the server. It's a little buggy because if the command, if the binary is absent, right, the error messages look they're very operating system specific. And so you have to troubleshoot around those things. But so you start with common binaries that you know exist on Linux and Windows. In any case, once you have RC, right? Once you have the ability to run commands, you want a shell because nobody likes the cumbersome way that SSM works. You send a command, then you have to get a command ID, then query the command ID to get the output. So what we did was we ran a bash reverse shell, and we caught the shell on our side using netcat. As simple as that. Oh, so if you notice the difference in the previous command, this was send command. Here, we're using the document name as AWS run shell script, and you can provide the command directly in the command itself. What if you have like longer command with multiple lines and stuff? You want to run an entire script. You can host it. You can host this bin bash and this reverse shell piece on an S3 bucket, a public S3 bucket that you own, and then point the S3 bucket as a path here, and in the command that you would execute. AWS pulls the file from the public bucket, downloads it to the machine, executes it as a rule, and because your script has the popular dev TCP reverse object, you get a reverse shell back on the machines who have IP address you've provided there. You had a shell, right? So case 3, client side keys, IAM policies and a vulnerable lambda. So you get an idea of where we are going with this. So there was an app, as I mentioned, the resume application earlier. There was an app that we were looking at, and it pretty much appeared to be static, right? There was, however, the functionality that the app was uploading stuff to an S3 bucket. At the beginning, there was this website, Star Trek Butter Corporation. There was a resume. There's an upload functionality basically on this. Ignore the URL. This is just to show that this was also hosted on an S3. The web application was a static HTML site with functionality to upload stuff. A quick review of the JS, and by analyzing HTTP traffic using Burp, we realized that the contents of whatever you were uploading was being written to an S3 bucket. Right? How was the static site writing dynamically, writing files to a server-side stuff, a server-side object? What do you think? If you've ever looked at JS in any web application test or assessments you've done, or bug bounty or whatever, what allows JS, which is static on the client? XHR, fetch. Okay, these are functions that allow you to make the request. But how is the right
key?
Right. So for S3, we know that IAM users or IAM roles would work. However, an IAM role requires a compute environment to assume the role, right? With EC2, for example, which is the most developers end up doing this. They create an IAM user, right, and they add the access key and the secret in the JS, right? And this is a very common example also available on the internet. If you Google for, search for static site write to S3, a bunch of them, even in Stack Overflow, will have information that says, hey, yeah, create a IAM user and put the access key and secret key here. Again, this by itself is not a problem, because if you've heavily locked down the IAM user that allows you to write files to a single S3 bucket and not read from it, you're good, right? It's like allowing somebody to walk into a hotel room, and allowing access to only one particular room, right? As long as your application is doing that, as long as the IAM user is locked down to that extent, you're good. However, it was not the case with this particular user. We added the credentials to our local system, AWS configure new profile, upload creds, and we ran scout route, right? Pretty useful. We were able to discover that the credentials actually had administrator access policy. Okay, I'm exaggerating a little bit here. The key had a bunch of administrator access condition services on EC2, S3, Lambda, and a bunch of RDS as well. But as good as administrator access, because as an attacker, if you have access to S3, EC2, RDS, and a bunch of these services that are mostly used by developers and where all the meat of the organization can lie, it's good enough for you. We were able to discover because we had access to, it was an administrator access key, right? So you could essentially look at the entire AWS platform itself. I looked at Lambda, right? The account had multiple Lambda functions. One of them performed a rudimentary function where it accepted user input and gave the MD5 sum of a string. Right? Internally, this Lambda function was being used to compute the MD5 hash of a particular file. The file that was being uploaded, written to S3. The file's MD5 hash was being computed using a Lambda function. Okay? Horrible design, but you essentially pass a string and it would give you back the MD5 value. Right? We downloaded the Lambda for analysis, essentially running list functions. You get function, it gives you the signed URL, and then zipping the Lambda function, downloading it. List function showed us the function. The get function with the function name gives us a URL. This is a signed URL, right? All you have to do is then paste this in your browser or wget this, and you have the source code of the Lambda function, right? This was the code. Can you spot the bug? The functionality is you give it text, it returns MD5, sum of the text. Tell me line number.
19.
19. Okay. But there are multiple bugs in the code. The one that would possibly allow you to do an RC is on
13.
Look at line 13 carefully.
13. 13.
Right, so if you see these, there is some level of, the devs have already thought, oh, this, semicolons and ampersands are going to be a problem if somebody is going to try and do an RC on this lambda endpoint, so let's filter them out. So semicolons and ampersands are being deleted, right? However, what other character? Backticks. What are the characters? Slashes. What are the characters? Pipes. Right? If you notice, CMD is echo n. N is to print without a new line. This is how you are computing the MD5 sum. Echo the value of the string, pipe it to MD5 sum. Okay? You can control string. Right? So you essentially pass whatever value of for the RC that you want, whatever code you want to execute for, whatever binary you want to execute, as a pipe, and then the binary that you want to execute, ID or whatever, and then another pipe. Right? That's what it did. We were able to execute commands on the Lambda instance. However, again, as proof of concept, we wanted a shell. We could have got a shell inside the Lambda, right? And once you've got a shell inside a Lambda function, Lambda has a bunch of environment variables that has additional information about the system, about the environment where it is running, right? Lambda itself, if you get a shell inside a Lambda, it's very trivial to set up a system that allows you to get a shell within Lambda with a maximum runtime of maybe 15 minutes. You would be able to see what all files and functions are present within a Lambda function. And applies to all other providers as well for their serverless runtimes, serverless services, right? You'll be able to figure out, see what the environment looks like. You'll be able to see what environment variables are present. In all of the cases, you require the environment to have access to some tokens so that you can perform some authenticated actions, right? So to a Lambda role in AWS, you can attach an IAM role. Just like you can attach an IAM role to EC2 instances, you can attach to a Lambda function as well. This Lambda functions, assume role, tokens are available within the Lambda execution environment. So if you have access to the environment, you can run env, for example, and print out the contents of the environment variables, right? And then using those, reassign them to maybe an AWS configure to another profile, and then add them to a new session. And so you have more access. We were able to get a shell on a particular instance. We had access to the administrator credentials for a policy with administrator access to AWS anyways. So we looked at other instances and we were able to get a shell in another sales server. We actually got root, right? So I haven't put that screenshot here. Yep, that's all I had for the 3 case studies. I'll take questions if you have.
Sorry, I missed the part where how did you privilege split from this user to root?
Oh, this user had sudo.
Okay.
Sudo I would give you root.
Thanks.
Ubuntu is the default user that EC2 has. Right, so if you've created an Ubuntu from an Ubuntu image, there are others. EC2-user is another one, right? Or CentOS. Bunch of these users, when you create an EC2 instance for the first time, they are assigned sudo privileges. And I'm executing stuff as root anyways, using instance connect, right? Or SSM command because I had administrator access. EC2 instance connect allows me to send an SSH key to a server, add it to authorized keys, and then an SSH tunnel is open. An SSH session is open using the SSH binary on the system. So the AWS bit of the API transaction is where a public key that you provide to AWS is sent to the server using the credentials, the AWS credentials that you are running the API with. Those are added to the system, and then an SSH session is open with the user that you want. The adding of the key is taking place in the root.